So when you open ArcGIS Pro, this is the interface that is the current interface for the program. If you haven't updated your ArcGIS Pro in recent times, I might recommend updating it as soon as you can. There's a lot of new features that I'm going to go over today that are only in the newer versions of this tool here. So the easiest way to do that is just make sure whenever you open the program, there should be, say, for instance, a window that pops up that says you're ready to update the tool, and just make sure you're updating it. What I'm going to do today is I'm going to start a new map and just go over some basics about the user interface. What I'll always do is just basically click on this map button right here. And we'll just create a new project. So I'm going to call this demo. And we'll just click OK here. And so typically when you start a new project, this is what is shown. You basically get an interface like this with a base map on the middle, the table of contents to the left, and a catalog to the right of your screen here. The most important thing that I always emphasize to students early on is make sure that you set your coordinate system for your map and play around with that idea of the projection, the coordinate system of your map, because most students, especially people who are new to this program, don't do anything. They just use the default system that you see here. So the way to do that is you simply go to the table of contents on the side here on the left, and you double click on the map line at the top of the table of contents. And then there is this button called coordinate systems right here. And in here, you can basically set the projection of this map. And so anyone who's studied geography or map making or cartography in the past knows that there are a lot of different types of projection systems for the globe. The world is a sphere. So basically, you have to take the sphere and you have to find some way to flatten it for a map. And the best way to test that is just to simply go to this world option here, opening that, and just seeing all these options here, and basically just picking one and seeing what result you get from that. And so if you test all these different options, you will find some options that work better for certain areas and options that work worse for others. Say, for instance, let's go to this fuller coordinate system right here. This is the one that basically takes the surface of the Earth and triangulates it, and then just kind of like unravels it in this way here. So this is a very famous coordinate system. The one that you all probably are most familiar with, and it's not a bad one to use, is what's known as the Mercator coordinate system. So what you can do is you can type in a coordinate system in this line here and search for it. So I'm just going to type in Mercator, hit enter, then I'm going to go to the world line there, and then option called WGS 1984 World Mercator. This is the one that, say, for instance, if you go on Google Maps and you zoom out of Google Maps, it uses a coordinate system like this. And this is a generally an okay one to use for most maps that are at this kind of global scale here. One thing that you also need to set up in this as well is your base map. So if I go to the top ribbon, the interface here, and go to this map button right there, you'll see all these buttons there. The one that we will play with right now is this base map button right there. So I click on that. And then in here, there's all these base maps that you can use to set the background for your project. The one that I most commonly use is imagery, or imagery with labels. So I click on imagery. If you zoom in, it automatically changes the image to a different resolution depending on the area that you're in. So I like to start with this imagery background as my starting point usually whenever I set a map up. Some other things about the basic interface here. Again, the other thing that we need to set up is our catalog. So if you don't have the catalog pane on the right-hand side of your screen here, you can always go to the View tab at the top, and then simply click on the catalog pane there, and that should pull it up. And then I would just dock it to the right side of my interface there, just so that I have it there on hand. We need to connect to data so that we can add data to our map. And so the way to do that is you basically go to folder level of this catalog, right click on that, and then choose this Add Folder Connection option right there. And in here, you basically dig through your computer's Explorer and basically locate where you put your data in. And so the data that I put into Box, I already have downloaded onto my computer. I have everything in my own GIS folder. And for this initial tutorial, I'm just going to choose the USA option. What should happen is that when you drop down this folder button here, you should see that USA option right there. And so now what you can do is you can, but let's say, for instance, you want to go into, let's pick an option here. Let's try this one, SM country. If I bring that in, that brings in a shapefile, features some of the countries in North America. Another one you can add, say, for instance, is in census and in states right here. If you drop that down, you can bring in the United States of America. That allows you to, if you simply click on the symbology icon right below that state line right there, you can either pick from a series of pre-made symbology options, or you can simply go to this properties button there and then change, say, for instance, the color and outline color. So if you want to, say, for instance, do a very simple outline of the states, you do a color of basically no color, and then an outline of, say, black. And then you can hit apply right there, and you should see a simple line word map of the United States. The next thing that I wanted to, all right, so the next topic we'll look at is the topic of data mining. This is basically how you would go about finding information and data that you would use for projects, like, so that you're starting a project for the first time and you need to know where to go to find data. And so I have a few options for you all that you can use to always start a project with. Is this website right here. It's this OpenStreetMap data extracts link. And in here, it's a very, very nice resource where you can download OpenStreetMap vector files for pretty much any location in the world, actually. Basically, what you do is, let's say you want to go to an area in North America. Let's say we're going to do Louisiana because we're going to be in New Orleans this semester. We'll go to North America, and then we will go into United States of America. And then you have all these states, and then you can basically click on Louisiana. And then what you do is you download that right there, the Louisiana latest free.shp.zip. And so if you download that and then extract it, what you get, and then go back to GIS, is statewide data for Louisiana. And so I'll show you what that looks like. What we'll do is we'll do the add folder again. So I'll go to the catalog folder, add folder connection, and then I'm going to go to state Louisiana, and I put my OpenStreetMap data right here. So I'm going to click on that. And so now this is in my catalog. And so let's say you want to bring in water. So we'll go to this one here. You see it has a very strange labeling convention, GIS OSM for OpenStreetMap. But if I bring in water, and then you can see in Louisiana, some stuff has come in, and I zoom into there. And essentially what you get here is a pretty good database of water features for the state of Louisiana. And you can see if I zoom into that, there's a lot of good detail. This is New Orleans. This is our site for the semester. There's a lot of features here that you can use as background vector data for, say, for instance, a Basemap or something. The other thing that you should be aware of is how to view information about each feature in the map. So the simplest thing to do is just click on an object, and it will give you a pop-up window of some basic info. So in this case, it's Lake Pontchartrain. Another thing you can do is you can go to the attribute table. So if you right click on any feature, you should be able to choose this attribute table option right there. And then that will give you a tabular view of all the information that is part of the data set. And also, say, for instance, its category, in this case, whether it's a river, a riverbank, a lake. And so a very quick way to symbolize that is to simply right click on that layer, going to the symbology option for that layer, and then a symbology window should pop up on the right. And then what you can do is in this drop-down menu right here where it says single symbol, you can click on that and choose this option called unique values. And then what you can do is you can symbolize each feature by, say, for instance, its category. And so in this case, F class right here, this refers to the feature type whether it's a riverbank, water, or wetland, and you see it gives it a different color. So now if I, like, for instance, turn this off here, the background layer, you can begin to see that the information now is makes a little bit more sense, where you can basically distinguish the different wetland types from other water types as well. And then you can go into each one of these options here and say, for instance, you want to choose riverbank, just click on the square, and then you can format the color and the symbology. So this link here, National Map Viewer, is a website that is managed by the federal government, the Department of the Interior, which basically manages the lands of the United States. And this is a very, very, very good resource for finding basic land use, land classification, and topographic data for the United States of America. You zoom into an area that you want to download data for. Let's say, again, we're going to go into the New Orleans region as our case study here. What you do is you first go to this button right here in this area of interest section at the upper left corner of the webpage. You'll see this button called Extent. I'll click on that button, Extent, and then just simply drag a box into that window of the area that you want to download data for. And then what you do is, once that box is drawn, you click on the data type that you want to download in that region. Pretty much, I always focus on these two lines right here: elevation products or elevation source data. Let's start with this one here, elevation products. I'll check that box. And this basically allows you to download digital elevation models, or DEMs, which is topographic data for any region in the United States. And I believe for today's tutorial, I downloaded this 1/3 arcsecond DEM file right here. Basically, all you really need to know about what these numbers arcsecond mean is that the smaller the number, the higher the resolution of the data that you download. And so, for instance, 2 arcsecond is a fairly coarse resolution, where 1/3 is very good at a regional scale, and 1/9 arcsecond, this one, which is the smallest resolution that you can get off of this website, is sufficiently accurate for, say, for instance, site design. Today, we're just going to focus on this. So what I did already is I downloaded some DEMs, and I've already saved it to the box. But basically, the process to get that is I just check this 1/3 arcsecond DEM there, and then you just choose the search products button in the upper left of this interface. So click on that. There we go. And then you see basically, if I hover over these options here, you see these little rectangles. These represent the tiles that you can download for this area here. So what I did is I downloaded a bunch of those and I put them into this zip folder right here, this USGS 1/3 arcsecond DEM. So if you want, you can practice downloading it. The way you would download it normally is just click on this download link. And what I'm going to do is I'm going to go to catalog, and I'm going to connect to the folder that I put that stuff in, and I put it into this folder here, this DEM folder. So hopefully, if you follow along, you should see data sets that look like this USGS 13. That 13 actually refers to that 1/3 arcsecond resolution. And if I bring that in, just dragged it in, a raster. Let's bring another one in. There we go. This image here that represents the topo of New Orleans region. So if you're bringing all these tiles, let's bring in all the tiles together. You'll see that this represents kind of like the general topography of this New Orleans region right next to the Gulf. Now, one thing that we're going to do is you're looking at this right here and you're thinking that it's great, but they're tiled, as in, like, you know, the relationship between this tile and that tile and that tile and that tile isn't consistent. So in order to merge all of these together into one thing, we need to use what's known as Mosaic Dataset. This requires some processing in the Arc toolbox. So in the top ribbon, in the View tab at the top here, there is this geoprocessing pane right there. I click on that button, and that brings up geoprocessing on the right side of the interface here. And the easiest way to find tools is to search for tools using this upper search bar right there. So I'm going to search for Mosaic. And there's several options that you can use to create a Mosaic dataset. This Mosaic to new raster option right there. So I'm gonna click on that, mosaic to new raster. And what it's asking for right now is in the first line input rasters. That basically means the files that you have as raster data sets that you want to merge together. So I'm going to click on this little arrow right there, and it brings up all the potential rasters you can put into this function. I'm going to check all those rasters that we brought into the map, then choose this add button at the little tiny corner of this window. That brings in all these rasters. And then it's going to ask for an output location. So I'm going to click on that folder right there. And we're just going to save it into the DEM folder. In my case, I have a folder called DEM. You can choose any folder that you have on your server. You can also put it into your geodatabase folder as well. I'll just put it into the DEM folder. Actually, no, I'll do this. I'll put it into the demo folder right there. And then you give it a name. So we'll call this one, let's call it NOLA region.tif. You need to put the extension of that file. So all raster data sets in GIS are TIFF files, so .tif files. And then you need a spatial reference. Basically, you need to tell this new raster what coordinate system it's going to use. What I recommend doing here is simply just choosing this drop-down menu here and then just picking one of the original raw rasters, because there already is a coordinate system associated with each of these rasters, and you don't want to mess with that at this point. So just click on one of the ones you added in, and then it automatically brings in the coordinate system that is associated with that raster. All right, the next line here, this is a little bit of a tricky thing, is this pixel type option right there. There's all these options here that you can choose from. The key thing here is you want to make sure this pixel type is consistent with the raw data that you've downloaded. So the easiest way to know which one to use for this line here is just to go into one of the raw data sets in your contents panel on the left side. So I'm going to click on, say, for instance, this one right here that I added in. I'm going to right click on that, then choose properties at the bottom of the right click window. And then you can go to this source tab right there. And then in this drop down area right there, raster information, if I go through here, you'll see that all these numbers but right here, pixel depth, 32-bit, floating point. This is the information that you need to match for this function here. So remember 32-bit floating point. And then what we're going to do is we're just going to do this one here, 32-bit float right there, 32-bit float. And then the last option is number of bands. This is not like musical bands. This is not your favorite number of bands that you go to concerts for. This is the number of bands in terms of the number of like light bands that compose this raster here. Again, you can go into the properties tab here and go to raster information. You can see right there, number of bands is 1 for this data set. So just put in 1 right there, 1. And if you follow all my steps exactly as I've described it right here, you can just choose this run button down there, and that will combine all these rasters together into one beautiful, consistent raster. So let's let that run. And just as an aside, I love this stuff. This is my favorite topic to teach. And I hope you all share my enthusiasm as the semester progresses. Cartography and map making is one of those things about landscape architecture that we get to do. Architects don't get to do this. Urban designers do get to use GIS, but urban designers tend to focus, I would say, more on the city scale, the urban scale, and more about the planner level. So that deals with things like parcels and lots and land use and those issues. But as landscape architects, we deal with environmental issues. And so we a lot of times break down administrative boundaries, and we just look at the earth as we know it. And so this here is what's great about what we do, is we get to really take a close X-ray view of what is happening on the planet and make maps and communicate this information to the public to get them to understand what's going on. So let me show you what I mean by that. So this right here is the New Orleans region. In order to change the colors of this map here, we click on the symbology button right below that TIFF there. So I click on this there, and then that allows you to choose a different color ramp for that area. So there are some really bad ones here, rainbow ones, ones that have really unfortunate color mixes, but there are some good ones as well. So some of these ones right here in this elevation section right there, if I hover over the options, you see it has elevation 1, 6, 7. These are pretty good. And I'm going to choose this one right here, elevation 8. And you can see that is beginning to start looking like a real map now. And you can begin to understand why we're choosing New Orleans, why this is an area that is fascinating to study. And right now this map is basically representing the gradient from the highest point to the lowest point of this particular data that I've given you. You can modify the breaks and the statistics of this so that it represents it in different ways. So in this stretch type line here, you can choose, say for instance, standard deviation, and that adjusts the range of values ever so slightly, so that some areas that might have been, let's say, blown out, because like this general area in the regional scope of things is flat, and so the topo change is hard to discern from, say for instance, these more hilly regions to the north. And so messing with these stretch types here allows you to kind of read the topography a lot better. Another really cool thing you can do is to modify the statistics of this map here to only visualize the high and low points of what's visible within the viewport. And so in the symbology tab right here on the window on the side, there's a statistics button right there, window, and there's this dynamic range adjustment option right there. If I click on that, what happens is if I zoom in to the map, you'll see that the symbology is adjusting so that it's constantly making the range of the highest and lowest point match what you just see on the screen. So this is like symbolizing the map for dummies, because you want to, you say for instance, create a map for the New Orleans region, but you don't know what's the highest and lowest points. You can use this dynamic range adjustment tool to help you do that. So I just zoomed into New Orleans. Let me choose a different color ramp. Let's choose, I'm gonna zoom down here to one of my favorite ones. One of my favorite ones is this one right here. The one that looks like a red to yellow to blue continuous. Click on that. And so this is why we're choosing New Orleans as a site. And if you zoom out of this area here, you see this is a very weird looking topographic map. New Orleans, as you get into the literature and you get into the history of the city, New Orleans is a sinking city. It's one of those places in the world where the city is lower than the ocean. It's lower than the Mississippi River. And so the color ramp here you see here, the high points are in blue and the low points are in red, according to this legend here. And if you zoom into this area here, what's happening, what you're seeing is that the Mississippi River is actually higher than the core of the city. And so what's happened over the history of New Orleans is that through the process of essentially draining this swamp, this wetland here, it's caused the entire area in the center of the city to essentially sink. And this is one of those reasons why when we talk about New Orleans, we believe, unfortunately, thanks to climate change, this city is basically probably going to be underwater in the next century just because of rising sea levels. At some point, that water is going to breach the levee wall, and it's going to have no choice but to basically flood this city. When huge hurricane events happen, say for instance Hurricane Katrina, those are devastating for New Orleans. But it's just one of those really interesting topographical anomalies in the world. You can see, everything else in this region generally looks normal, but then right here, New Orleans is this very interesting topographical anomaly where, say for instance, right here, this is not fake, this is real. There is an area where there is a levee / flood wall right here that's protecting this neighborhood from the area around it, which is higher. So it's a very interesting topographical condition. But in terms of just the GIS portion of this, this dynamic range adjustment tool right here, it just makes it so much easier to visualize the gradient so that it matches whatever you're looking at. If I don't use that, if I say just, for instance, use dataset, you see that it doesn't change it according to the viewport. It simply keeps the range that you've set already here. So that is a very fun way to visualize topography in that area. Another website that you should look at is this one here called Earth Explorer. Let me copy and paste that into the chat. Earth Explorer. So Earth Explorer, this here is that you can use to download more continental data, not just in the United States, but across the entire Earth. This, again, primarily I use for topographic data. And if I want to, say, for instance, get topo data for a certain region, I would use this. The way that you utilize this tool is you just simply click into the map here of an area that you want to download data for. So in this case, I'm just going to like click 4 times around the US region. And then in the bottom left corner of this window there's this data sets button, and you'll see all these data sets that you can choose from. So what I downloaded was one of these digital elevation data sets. And I believe I downloaded this one called GTopo30. So I click on what I do is you basically check that box and then you choose results. And there are these more continental scale data sets that you can download. So again, you can click on one of these, the footprint and the preview there to visualize what that data is. And so you can see this is digital elevation data for a larger portion of the world. It's lower resolution if you zoom in, but it covers a larger area. And then what you can do is you can download that data from this website using this download options button right there. So I click on that, and that allows you to download a GeoTIFF, which is the TIFF file that you want to use. I've given you a couple of data sets, 4 data sets, in fact, of what you see right here. Go back to GIS, and I'm going to zoom out a bit. Oh, other thing that I wanted to mention that I forgot to mention is that whenever you set up a project in ArcGIS Pro, you don't need to work within just one map. You can actually add multiple maps to this. So right now I have this one map, and let's say, for instance, I want this particular map, and it is already kind of focused on this New Orleans region right here. Just leave it like that. In order to create a new map, just simply go to Insert, New Map. And so what we'll do is just click on New Map right there. And then you all of a sudden have a new map, as if you started a new project. But when you save this model, it keeps both in one project. So that's a nice thing about ArcGIS Pro, that as it compares to older versions, where older versions of this program only allowed you to have one map per project. Now you can have as many maps as you want inside one project. So in this particular instance, we're going to use this to add in that regional topo data. So let's do that. Let me go into Add Folder Connection, and I'm going to go to the continent. And then you should see these G30, GT30 TIFF files there. You will also, I believe, see this North America GTopo_2. This North America _GTopo2 is the exact same process that we did to create this, where I basically dragged in the raw files and then I merged them together using that Mosaic to new raster function. So I've already, just to save you time, combined all that into one giant raster data set right there. Let's choose this one here. If you zoom in to, say, for instance, the United States, you can begin to see that as you zoom in, it will change the symbology of it to just simply represent what you see on the map. And so this is really nice for really quickly making sure that you're maximizing your symbology so that you always have the highest and lower colors depending on what you see. So if I zoom into New Orleans, you can begin to see the detail of that begin to emerge through. If I zoom to other areas, let's say, for instance, the other portion of the southern half of the United States, you can see that, it changes as you go. So this is really, really fun to do. And I would encourage you guys maybe in outside of class just to bring this tool in and just download it and play around with that. I wanted to show one more thing with this. We'll get more into visualization later with this stuff here, but I couldn't resist showing you my favorite map style. And that is the use of a hillshade overlaid on top of a gradient map like you see here. And this is a good opportunity for me to also show some features that are in ArcGIS Pro that are new, that are really cool. Also, one thing I will do, you'll see that this coordinate system here is a little bit, maybe not the right one for this area. One thing you can do as a cool version of, let me actually I turned it off. Let me turn the imagery back on. A cool coordinate system that you can use is the world from space. And so what I'm going to do, I'm going to double click on this here, and I'm going to search for space. In projected, there is this world from space. So I'm going to choose that and click OK. And you see what happens is that it takes a map and it turns into a sphere. And so this is I like this one because it does not try to flatten the surface of the Earth into a rectangular plane or something. It just imagines you are in a spaceship, and if you are at this particular position in space and looking at the Earth, what does it look like? And so if you want to have an image of the Earth as, I would say, for instance, a visualization, you can use this one right here as an option. And let's say you want to center this image on like the United States. An easy way to do that is just hover your mouse kind of over the general area that you want to center the map on, and then look at the bottom of the map frame. I'm not going to move my mouse because I just want you to see that at the bottom of the map frame, there should be a series of coordinates. Right now it's set to like 96.9 west, 37.5 north. So we got to remember those numbers, 96.9, 37.5. And then what we're going to do is go in here, go to that coordinate system, right click on that, choose copy and modify. And then you need to set these numbers here to be the, I think it was a 96.9, 35.7, save, okay. And now you've centered the area onto the Google. So this is one way you can create a cool looking map. But what I wanted to show you was the concept of combining hillshade with the topography. So the way you do that is you need to create a hillshade data set. And you guys should remember this from grading because I taught you how to do hillshade. This is a review. But basically, you go to the geoprocessing window there and you type in hillshade. And then there should be a hillshade option in top. There's two versions, 3D Analyst and Spatial Analyst. They're exactly the same. You can just choose whatever one you want. I'll choose this one. And then input raster will be the map, the raster data set. And output raster, you basically just choose a location for that. So I'm just going to save this into my demo folder there. And then I'll call this one hillshade demo.tiff. And then just choose run. And that is very intense. So I'm not sure why it came out really intense like that. But what we can do is we can, actually, let me show you another way to do this. This, for some reason, it came out really intense and I don't like it as much. You can also use the raster function. So what you can do is you click on this topo layer right there, go to analysis, and then at the end of the raster ribbon, the analysis ribbon, there's this thing called raster functions. So click on that. And then a new raster functions window comes up on the right. And what you can do is you can go to the surface option at the base right there, then choose Hillshade. And then basically you can choose that topo data set again, and then choose create new layer. And that's a little bit better. Let me see if I can improve the statistics of this. So I'll go to the contents on the side. I'll click the symbology tab. Let's see if I choose this. Yeah, so now it's a little bit better. If I zoom into that, you'll see that it creates this really nice, subtle topographic, almost 3D looking rendering here. What you can do is you can apply Photoshop style filters to this. And so the way you do that is you click on the layer that you want to apply a filter to, go to the raster layer tab at the top while it's selected. Then right here, there's this layer blend drop down right there. Right, click on that. You see all these Photoshop style filters you can use to create a filter. So, multiply is one that you should all be familiar with. I choose that. What happens, you can see, is that it basically takes that and just applies that filter so you can see below it, but then the dark areas kind of enhance the topographic quality of the image. Another one you can choose, say for instance, is the overlay. And so anyone who uses Photoshop knows these modes, and you can see that it begins to enhance the topographic quality of it a lot more. If I zoom into, say, for instance, some regions, you can see how that really does a lot of work to help give it a three-dimensional quality to it. Another thing you can do is you can apply filters on this layer right here. So if I click on that, go to raster layer and then layer blend, let's add that, say for instance, create a color filter like so. You can see what basically does is it colors the surface below that. That didn't turn out quite as good as I thought. Let's try hard light. That's a little bit better. But you can see basically it takes that raster layer and it applies a transparency filter to it like you would do in Photoshop. So in a way, GIS is becoming a lot smarter, where instead of exporting out layers and layers and then compositing them in Photoshop, you can do a lot of the work already straight into GIS and begin to compose topographic maps straight in here and then exporting those out with less post-processing. And so I'm going to show you guys a trick that I've become infamous for, which is how you can take live map data that you might find on a web page and bring that into your map and download that data. The simplest way to find GIS data for any region is just go onto your search engine, Google or whatever, and just search for, say, for instance, New Orleans GIS data, right? If I do that just as a quick example. So I just searched for New Orleans GIS data. Let's go. What I did was I went to this first link right here, City of New Orleans GIS. Click on that. And I went to one of these live maps. I believe I went to the one called Cultural Economy right here. And what you do is in your browser, once you have the map open, you go to the browser's developer settings and right there, developer tools. So I'll choose developer tools, and that brings up this window on the side that displays the links and sources that the data is being streamed from for any website that is hosted on some kind of ArcGIS run platform. Most, say for instance, most city planning websites use ArcGIS as their platform. You will probably see a link. If I hover over these links here, some of the links work for what you need, some of them don't, but there will usually be a link. And this is the link that we're going to use. I hover over that. Let me copy that. I'll hover over this. I'll just simply do copy. Yeah, there we go. There we go. And then open Notepad, and then paste that in there. What you're looking for is this. You're looking for a URL that has this at the end of it, REST services, right there. But you're looking for this REST services URL. Everything that's after that, those two words, REST services, you don't need. So just copy that, Control C on my keyboard, copy that, and then go to ArcGIS And I'm going to go back to the New Orleans area that we were studying. So I'm going to this first map right there. So that's the New Orleans. And I'm going to go to the catalog on the side there. Oh, not yet. It'll come up in catalog in a second, but you won't be able to see servers just yet. What you need to do is you need to go to the Insert tab at the top. Then there's this Connections drop down right there. And then there's a Server window right there. There we go. And then there's Add New Arcgis Server Connection. That's what you want to click. So click on that. Paste that link in that top line right there. And then click OK. And now in the catalog, you'll see a servers folder. Now you see that server link, and if I expand that, you should see all these folders. So the cool thing about this, again, this is all the data that's on that server. And so you just need to go do that, and you need to look through that folder and find your data. This is a very nice way to dig up interesting data sets. Let's just see what we got here. We got tree canopy right there. So let's choose that. And we got tree locations. I'm going to click on that and bring it in to the map. And it brings it in right there. You see that's grayed out. This arrow is grayed out. That means that when you see that, that means it has a visibility range associated with that. So the easiest way to fix that, just right click on this and just choose this zoom to make visible option right there. Choose that option, please. In this particular instance, you have a database of trees for New Orleans. And sometimes these data sets can be very useful. Let's see what we got. And you can click on one of these features. Let's click on, say, we got a palm tree right in that location right there, Queen Palm. I guess New Orleans has a very nice tree database. So this may come in handy at some point in the semester. One thing that you can do is right now, this data does not exist on your computer. It still exists wherever this server, the data is existing on the server somewhere. So you want to download this data. You want to bring this onto your computer. So you want to download this data. And the way you do that is you go to geoprocessing and you use a tool called feature class to feature class. So I click on that. And you should be able to, for a lot of data, a lot of vector-based data that you find via this method, say, for instance, tree location is a vector-based data set. Raster data sets are a little bit different. Maybe we'll get to that another day in the future. But you are now able to download this to your computer. And so I'm going to download this to my default geodatabase. You see, it always defaults to your .gdb. Just think of your .gdb as kind of like a specific folder specific to this project. It's not a shapefile. It's a different type of data set. It's a little bit more optimized. Say if you have no plans on sharing data with anybody in the future, saving stuff into your geodatabase is fine for now. But if you need to share things as shapefiles, that needs to change. Anyway, for this demo, I'm just leave that as is. Output name, we'll call this tree loc for tree locations, and then just hit run down there. And what's happening is it's downloading that data set from the server. You can see the percentage as it downloads that. And then once this finishes, you have the computer on your, let me go here. So this tree loc right there, that now is your data that's saved onto your computer. One way you can verify that, if you, in your contents panel, you see this little cylinder right there, list by data source. If I click on that, it lists out all the data with the location of that data. And so tree location, that was pulled from the server, but the tree loc, that you can see is on my desktop, see users, Frank, documents, blah, blah, blah. So I can just delete the one from the server and voila, you got tree data for New Orleans, woo. And what you can do is you can go to the attribute table. So go to attribute table and you have all the data for New Orleans. So let's do simple symbology. We'll go to right click on that, symbology. We'll use unique values to visualize everything by your, let's do the common name for now. All the trees in a visualized color on this, this plan here. And when we go to New Orleans, as you go along this street here, these are all palm trees. If I click on this here, date palms. What you can do as a cool little way to isolate specific species is you can go into the attribute table here. You can choose this select by attributes button. I choose that. We'll choose a new selection where the common name is equal to, and you just pick whatever tree you want. Let's say, for instance, we just do that date palm, just to see where all the palm trees are in New Orleans. We'll click apply, and you see those are highlighted now. And then what we can do is while those are highlighted, right click on the layer in your contents. In selection, there is this thing called make layer from selected features. So if I choose that, a new layer is going to come up. It doesn't create new data. It just simply isolates that data. And then I'll clear that. Then you have all the, let me turn off the background. It might be a little bit distracting. Maybe this is a better background. You'll see these are all the palm trees to the best, I assume, of whoever created this data set to the best of their ability. We'll talk more about attribute tables later in the semester, but the last thing I'll show about attribute tables is how to summarize data. So you want to know, all right, you got all these trees in New Orleans, but like how many of each one? So what you do is you go to, first you select the actual data set that you want to use. Then we go to data. Yeah, right there, summarize. So that's one way to do it. I was looking for this right here, summarize. It's in the table right there. So you can just choose table, summarize. It's going to choose that table. It's going to choose output table. And the field that we will use is the common name. And the statistic type will be count. Let's see if I can get this right the first time. And in the case field will also be common name. If I click OK, you see down here a standalone table. It creates a new table. And yeah, I did it. First try. You have a count for all the trees. And so let's sort this by descending, so from high to low. Ooh. But we got a lot of crepe myrtles by a significant number. Ooh. Wow. But there we go. That's an interesting way to take data and easily summarize that. So anyway, I went down a rabbit hole. It all started with this right here, just this simple going in here and like finding data and then using that feature class to feature class tool to get some stuff. There's a lot of good layers in here. Basically, you can find data using the Arcgis portal right here. So in the catalog, there's this button here called portal, and then you can search for data from ArcGIS online right there. Basically, people who use GIS, they create online layers that they just publish publicly, and you don't know what you can find out in the world. But what you can do, say, for instance, is go on ArcGIS online, search for New Orleans. Sorry, New Orleans, not New Orleans. It's Nolans, okay? And there's a lot of layers and maps that other people have created. Well, right here, New Orleans bakeries, right here. So you drag that into the map and it adds a layer of the bakeries. So we will hit all these bakeries when we visit later this semester, because bread is the lifeblood and the energy giving sustenance that we need to survive this trip. So we will hit all these bakeries. This one right here in the French Quarter, what's that? Renan's. They have brioche. This is really important stuff. Sugar, yes. Sugar, yes. This is the data.
How many bakeries are there?
How many bakeries are there?
Yeah, how many?
Let's go. I mean, there's probably more than.
I'm just wondering for our bakery crawl.
Yeah. There are 16 bakeries according to this data set right here.
Oh, yeah. Perfect.
Yeah. And we got traditional Vietnamese. Ooh, Vietnamese. That's great. And I believe you can use the same exact feature class to feature class if you want to say, for instance, download these points right here, and you can download those points the same way. So you have to, Helene, I'm guessing that you did this. You brought in this. I would recommend bringing in the thing with the yellow looking thing. And I think that should fix it. We will chat more about this. And so hopefully you see now, this is kind of how I'm going to run this class is I'm going to give you skills through these work sessions. And then it's up to you guys to use them on the studio assignments.